I'm Sandeep, by the way. I'm a Senior Product Manager for Nimble Cloud Volumes. Been with Nimble for more than 4 years now, and been with this product since its inception. So let's start with the demo. As Gavin was saying, this is a cloud service. So all I need to get started with is my laptop and a browser on my laptop, right? Of course, it has an internet connection. What I'm going to type now is cloud.nimblestorage.com. This is our own cloud. This is the place anyone can go and learn about this service. You'll find all the information about its features and its pricing as well. Now, as we mentioned, this service is in beta right now, and that's why it has two links. One, to request access for beta, and second, for people who have beta access to go in and start using beta. Since I'm one of those fortunate and excited beta users, I'm going to go and log in. It's going to ask me for my credentials, which I'm of course not going to tell. So welcome to Nimble Cloud. This right here is an interface that lets you provision, manage, and monitor Nimble Cloud Volumes across multi-cloud, multi-geography, and at the same time, this is a multi-tenant interface. So let me explain that one by one, right? As you can see here, I have 3 Nimble Cloud Volumes. 2 of them have been provisioned to be used by AWS, and 1 provisioned to be used by Azure. One of the volumes in AWS would be used in the US East, which is the Virginia region, and one of the volumes in AWS would be used by US West, which is the Oregon region.
Can you have a single volume be accessible both to Azure and AWS?
Not in beta, but that is definitely a possibility. So what we have heard, although, is give a volume, create a clone, and access it in a different cloud, and that is, again, a possibility. So what I'm going to demo to start with is creating a new volume, right? And there are 2 ways of creating the volume. One, of course, is through this interface, and second is using APIs, and I'm going to demo both. So let me start by what I have in front of you. I'm going to add a new volume. I'm going to read this out because it's not coming very well on the screen here, but there are 3 steps in creating the volume. The first is specifying details about the cloud provider, right? So in which cloud do you plan to use this volume? I'm going to use this particular volume in Microsoft Azure. Which region of Microsoft Azure are you going to use this volume? I'm going to use this volume at East US. Picking some numbers. And then I'm going to enter some details about my cloud. In this case, it's Azure, so like a resource group and VNet. And some of this would be automated as we go ahead. We can take Azure credentials and pull this data from your Azure account, right? But this is beta. I'm entering it manually right now. The next step is around volume settings. Very basic settings, right? I'm going to start with a volume name. Because this is a storage fill date demo, I'm going to just say storage fill date demo 0309. And I'm going to create 2 volumes. So let's say this is the first volume I created. I'm going to select the size of this volume. Let's say 100 gigabytes. Something, not trivial. And then I can select an application that I plan to run on this volume. You can select others. You don't want to specify, that's fine. But how it helps specifying an application is that it helps in 2 ways. One, it allows us at the back end to optimize this volume for the application that you have chosen. And this is on basis of the things that we have learned from more than 10,000 customers over the last 7 years, I would say. But second, now we can take this as an input and correlate it with the InfoSight data that we have and give you some recommendations. things like given this particular volume size, this applications, how many IOPS should you be provisioning? Or what sort of snapshot policy should you have? All of that is not there yet, but once you specify this, these are the things that we can start doing for our customers. For now, I'm just going to pick certain IOPS, 3,000, And one thing to note here, so you can provision size and IOPS separately. There are two independent dimensions you can work on. The last choice that you have here is choosing which tier you want to allocate this volume from. We have two tiers. First tier is premium flash tier, which has performance SLA of greater than 99%. And second is general purpose flash, or we'll call it GPF, which has SLA of greater than 95%. So PF and GPF. PF is available right away. GPF will be coming out very soon. So I'm just going to select PF for now. Through my step 2 to step 3. The last step is, do you want to have snapshot protection on this volume? You can choose not to have, but we recommend you having. Manual errors happen. We recently saw one, big one. We in the sense, Amazon. So I'm going to select, in this case, a snapshot protection of daily snapshot with retaining 3 of those, right? And then I'm going to also have an option to encrypt this volume, right? So I'm going to say encryption is enabled. So this data is encrypted at rest.
Where are the keys kept?
So the key management is completely owned by Nimble right now. So we take care of the keys for you.
Internal to where were the keys?
Sorry, what was that?
Where are the keys kept?
So keys are kept with Nimble right now.
In that box in the cloud?
In the cloud, in our cloud. But as we go in future, we have plans of integrating with like Amazon KMS or Azure Key Vault. So that's something. So the last step of this provisioning experience is basically review what you have done and create a volume, right? And as I'm creating a volume, I want to emphasize that in all of this process, we never asked you to set up an array. We never asked you to set up a virtual group or a disk group or a RAID group. In all of this interface, you will never find a place where you have to manage an array or a version or anything. This is as cloud service as it can get. Now let's click open the volume that we just created. There are a few things you can do once you've created a volume. Of course, you want to use it with the compute that you have in the cloud. But on the top right, you see some graphs out there, which are right now placeholders. But this is where we'll pull volume level analytics from InfoSight to give you analytics on performance, analytics on space, things like days to full will be available there. You can also choose to edit properties of this volume. And I'm going to actually do a demo in my second part of this, where I can change the name, the size, the IOPS, or even the protection schedule, and it will take impact right away. I can attach this volume to a cloud compute by specifying the IP of my virtual machine. And I'm going to do that through APIs very soon, because in the limited time. And then I can take a snapshot. And this snapshot over here is thin, quick, nimble snapshot that will finish in 3 to 5 seconds, from which you can restore or you can delete that snapshot. But given the time we have right now, let me jump on to the other method. When we started this service, right, we definitely learned that being in cloud, APIs are as important as the nice fancy GUI. In cloud, people want to deploy infrastructure as code. Infrastructure is a code there. So what I'm going to switch to now, I have an AWS Windows instance in East US that I'm going to spin up through my RDP session. And what it has right now, I'm going to show, is it just has one boot drive, coming from EBS, 30 gigabytes. What I have locally is a script, which is basically a PowerShell script, which is a wrapper over our APIs, that is essentially going to do the same thing we just did through our GUI interface. It's going to create a new volume of 100 gigabytes 2000 IOPS, SharePoint application, protection, and most of the details are same. But what it is also going to do is connect to this volume from this host. So that is why it is taking an IP address as an argument, right? So it is going to fire off these these APIs on our beta.nimblecloud.nimblestorage.com, and I'm going to provision this volume in the US East 1, which is the Virginia region of AWS. So I have already copy-pasted this command on my PowerShell, just like a cookery show. I'm going to run this now. So let me minimize this by the time. Let me run this.
So it's going to call the Amazon APIs to actually connect your volume.
It's going to call the Nimble APIs.
You said you're going to connect it to the server,
Correct. Beta.nimble. So
Connecting to the VPC, right?
to the VPC, but so he's going to make the Amazon calls to do that, right?
let me just go back and run this command quickly for you.
On the Nimble side, they got to do the mapping, and then
Correct. So what this is going to, while it runs, I'll explain you what it is doing in the back.
cool.
Right. So that is the second volume I'm creating today. It's asking me for the credentials to my Nimble Cloud Volume account right now. So it's first going to talk to Nimble Cloud Volume. So these are the same credentials I used while creating. Now it will communicate with Nimble APIs, create the volume, and then we'll use some of the host APIs to connect to that volume. It has already been provisioned in that VPC, right? So as you can see, while this is happening, the second volume just appeared on the right-hand side, 100 gigabytes of Nimble Cloud Volume directly connected to Amazon EC2 host, right?
In this case, are you connecting to the Windows with an iSCSI initiator in the host, or are you connecting it like an EBS would be connected to the actual instance?
It's the iSCSI initiator in the host.
So I'm not doing any Amazon magic.
You're not.
I'm going directly from the instance, from the guest through.
Correct. The only Amazon magic that happens in the back end is all the virtual private cloud and virtual network setups, right? Okay. So there needs to be still the correct routing that needs to happen, and that's we take in the back end.
Do you get 10 gig connectivity in the guest, or is that 1 gig only?
So
The cost of the guest.
So you get
In
the
get 10
IOPS.
gig?
So we just provision 2,000 IOPS, so that's what you get, right? So it's based on whatever IOPS you provision, and the maximum limits are basically dictated by Amazon, and we can talk about it later, I guess. There's a 5 gig limit on Amazon and 2 gig in Azure, so we can talk about it separately. Right?
Right, but remember that's per instance, not per host.
Yeah.
So it's 1 gig per VM is very different than 1 gig
Correct.
for a VMware host.
That's right. And now, one of the questions we always get is your cloud is separate than Amazon cloud, and you also ask, what about latencies, right? So I'm going to use one of the popular tools, and you could have guessed, which is Iometer. So I'm going to refresh my target list in Iometer. As you can see, there's one Nimble volume discovered in Iometer. So my first test is going to be purely focused on latency, which means I have to have queue depth of 1. So 1 queue depth to just test latency. What I'm going to specify and access is 100% 4K random writes. So this is the one I've selected. And now I am going to go and spin up the test. So let me start the test. I don't care about saving the results right now. So as you would see here, the latencies between Amazon Compute to Nimble Cloud Volume are around 1.5 millisecond or less. And this is as good, if not better, from what you get in EBS. I mean, the only way to get less than 1 millisecond latency in EBS is by having an instant storage, which basically takes away a lot of the advantages. So I'm going to stop this test here. We are short on time. What I also want to demo is the IOPS part. Remember, we provisioned 2,000 IOPS. So you're not going to get anything more than that from this. Let me crank up parallelism a little bit to get to those IOPS. Let me show you the IOPS here, right? Don't care about saving data. And as you can see, this is the IOPS that we provisioned, and you would hit a wall once you hit 2,000 IOPS. There is no way you can get more in this case, right? Now, of course, you provision 2,000 today. 6 months later, you realize, I'm hitting 2,000 every day, so which means I need to have more IOPS. So what now you can do is go back to this interface. As you can see here, if I just filter by SFD, we have two volumes. One we created in here, two that just came in from API, 01 and 02. So if I go to 02, right, it has been provisioned for 2,000 IOPS. I'm going to go in and edit this volume. The property that I am editing is provisioned IOPS. From 2,000, let's go to 3,000. Mind you, these changes are instantaneous. So as these changes are taking place, they are done. Let's go back. And this is where the impact. We right away have jumped from 2,000 IOPS to 3,000 IOPS. So you are not stuck with a decision that you just made about 6 months back. You can go up and down. You can change your size. And this is the cool thing about a cloud service, right? You can provision an object and different objects of different properties and change them later. So this is the last part of my demo. But the other things that we have available are things like quick snapshots and restores. Very soon we will have cloning facilities. And the another exciting feature that we'll start adding is replicating between an on-prem Nimble to a Nimble Cloud Volume, both directions. And both directions make sense. Because for some people, they want to start locally, on-ramp to cloud later. So you want to put your money in an infrastructure that doesn't block you from going to cloud. So this infrastructure protects your investment from your future. The reverse direction also makes sense for some people. You have running a production in cloud, but you want to retain a copy locally because many people want a local copy for compliance. Some of their auditors ask, do you have a copy of your data? I think you have a question.
Yeah, I have a question. So has Nimble has not, as far as I've known, has not been used in a multi-tenant situation that I've heard of, where you have multiple customers running, multiple separate customers putting their data and possibly compliant data on one box. Has there been any evaluation or third-party evaluation of your of the fencing around volumes for something like this when you're going to have multiple customers' data on this, literally running on the same hardware?
So there are two questions basically you asked. One is, do we run into a multi-tenant situation? And we of course do.
I do, yeah.
We have service providers, which are one of our biggest growing segment, using Nimble as a backbone for the service. Okay. And one of the reasons we added QoS is for that, right? Mm-hmm. And you saw QoS in Gavin's side. So that's one part. We do have situations where we are running. The second part is about certifications. So yes, we are in process of getting a lot of the certifications. And I mean, this is something that we also look at our competition, in this case at AWS and Azure. They have a bunch of certifications out there, and over time we'll match those certifications. And there's things like doing penetration testing to our software that's happening right now. Right? So of course, there will be certifications, but at the same time, we are confident enough that this works because there are enough service providers out there using us as in a similar method.
And then just on the, sorry, this is not working. I think on the on-prem arrays, we do support multi-tenancy.
Yeah, he said,
yeah.
You mentioned.
Yeah.
Thanks.
All right. So because that's the end of my
I
demo.
don't see the concern.
Multi-tenancy, I mean, it's not that.
Because it's not like they're giving you that there's a multi-tenant UI on the array itself.
Well, it does. If I was able to get, spoof an IP and an IQN to connect iSCSI to somebody else's array, I'm not saying it's easy to do or it's.
Yeah, but I don't see.
There have been other arrays that do multi-tenancy that had those certifications done.
Mm-hmm. Yeah, no, I understand. I understand that.
So,
for the case like a 3-part where you have multiple tenants who are accessing the management interface of the array.
I also just don't want to hop out to someone else's data either.
Yeah, but with an interface like this where the authentication and the connection of the machine to the LUN so to use no better word, all happen as one piece.
Well, I get it. No, mapping should do that, right?
Yeah,
Just the mapping alone fizz it out, but again, third-party validation helps with clients to make.
Oh, no,
them
you
feel
know,
better about using the
I
service.
understand the, you know, we
I
want
understand
to,
the technical-
we want
yeah.
to show it to other people to make them feel better.
Exactly.
I look at it and I don't see I don't see a substantial risk
Just
compared
because
to,
no one's done it doesn't mean somebody can't. So we just want to make sure. I mean, we just haven't seen it.
Oh.
So, right? And so, bugs, holes. Who knows?
nothing is sufficiently safe from a sophisticated enough hacker.
Exactly. So just,
But that's a different question.
I'm just looking for validation. That's all.
And we use a lot of technology to sort of isolate customers.
Right.
One of them is like the portal access. You can only see your volumes. You can't see someone else's volume. If Gavin is another customer, he'll only
Right.
see his volume.
Right. Yeah. I'm trying to figure out making sure people can't hop in.
Yeah,
That's all.
but that's also partially inherent in the way AWS does networking.
Mm-hmm.
That one customer's network reaching out to their data center
Every
couldn't
piece
see
of- yeah,
another
yeah.
network.
It's true.
So there's a bunch of inherent protections that make me relatively comfortable.
That's right. All right. Thank you, guys.
Thanks.